Picture this, a billion galaxies scattered across the cosmos. Each galaxy is home to billions of stars, and around many of these stars, planets orbit, bathed in the warmth of their suns. It's a breathtaking sight, isn't it? Now consider the possibility that we are not alone, that somewhere out there, on a planet just like ours, or perhaps vastly different, life exists. For centuries, humans have gazed up at the stars and wondered, are there others out there? It's a question that has fueled countless science fiction stories and scientific inquiries. We've sent probes into the depths of space and scanned the heavens for signals. Yet, we haven't found any concrete evidence of extraterrestrial life. This is the crux of the Fermi Paradox. If the universe is so vast and teeming with potential for life, where is everybody? This question, posed by physicist Enrico Fermi in the 1950s, has haunted scientists and thinkers ever since. It's a paradox because the sheer scale of the universe suggests that alien life should be abundant, yet we haven't found a single shred of irrefutable evidence. So, how do we reconcile this apparent contradiction? Over the years, several theories have emerged, each offering a possible solution to the Fermi paradox. Let's explore some of the most intriguing ones. Imagine life in the universe as a giant obstacle course. To reach the finish line, that is, to become a spacefaring civilization, civilizations must overcome a series of challenges. These challenges could be anything from natural disasters like asteroid impacts to self-inflicted wounds like nuclear war or catastrophic climate change. This, in essence, is the great filter theory. Think of it like this. Humanity has managed to survive for thousands of years, but we've come perilously close to destroying ourselves with nuclear weapons. What if other civilizations weren't so lucky? What if there's a filter, a hurdle that most civilizations can't overcome, that prevents them from reaching a certain level of technological advancement? This filter could be behind us, meaning we've already overcome the biggest hurdle. Or it could be ahead of us, suggesting a bleak future where we might succumb to a yet unknown existential threat. The Great Filter is a sobering theory that forces us to confront the fragility of our own existence. Cosmic events like supernovae, black holes, and gamma-ray bursts could also pose significant threats, potentially wiping out life before it has a chance to thrive. Additionally, the environment of a planet itself could be a major obstacle, with extreme volcanic activity, toxic atmospheres, or lack of essential resources making it inhospitable for life. Only a few planets might have the right conditions for life to develop and sustain itself, making the search for alien civilizations even more challenging. Now let's delve into a more unsettling possibility, the dark forest theory. Imagine the universe as a dark forest where every civilization is a hunter armed with advanced technology. In this scenario, silence is not a sign of absence, but a survival tactic. Why? Because any civilization that reveals its presence risks being discovered by a more advanced, potentially hostile one. Think of it like two hunters stalking prey in a dense forest. A rustle in the bushes could signal a potential meal or a dangerous predator. In the same vein, a civilization that broadcasts its presence might attract unwanted attention. It's a chilling thought, but it highlights a crucial aspect of survival in a universe where we know so little about what or who might be out there. The dark forest theory suggests that the very act of communication could be a liability, forcing civilizations into a state of perpetual silence. This eerie silence could also be due to the fear of technological disparity. A less advanced civilization might avoid contact to prevent exploitation or annihilation by a more advanced one. Additionally, civilizations might develop advanced cloaking technologies to remain undetected, further contributing to the silence. The vastness of space itself adds to the silence, as signals may take millennia to travel, and civilizations might rise and fall in the interim. Finally, the silence could be a result of civilizations that have already perished, leaving behind only the faintest echoes of their existence. The dark forest theory, with its layers of fear, technology, and the sheer scale of the universe, paints a haunting picture of why we might be alone or simply unable to hear others. Let's shift gears to a slightly less ominous, though equally intriguing possibility, the zoo hypothesis. Imagine you're walking through a zoo observing animals from a safe distance. You wouldn't want to interfere with their natural behavior, would you? You'd simply observe, study, and learn. Now imagine advanced alien civilizations as the zookeepers and Earth as their exhibit. The zoo hypothesis suggests that advanced extraterrestrial civilizations are aware of our presence but choose to observe us from afar without making direct contact. Perhaps they are waiting for us to reach a certain level of technological or social maturity before revealing themselves. Or maybe they are simply content to study us from a distance, like scientists observing a fascinating but primitive species. The zoo hypothesis raises intriguing questions about the ethics of interstellar contact and the motivations of advanced civilizations. Are we being watched right now? Could there be eyes on us, studying our every move, waiting for the right moment to make contact? The idea that we are under constant observation by extraterrestrial beings adds a layer of mystery to our existence. It makes us wonder about our place in the universe and the unseen watchers who might be out there, silently observing. Now let's consider a more straightforward explanation for the Fermi Paradox, the vastness of space itself. The distances between stars are incredibly vast. Even traveling at the speed of light, it would take years, centuries, even millennia to reach even the closest star systems. This immense interstellar gap poses a significant challenge for any civilization attempting interstellar travel or communication. Imagine trying to have a conversation with someone standing on the moon. Your words would take about 1.3 seconds to reach them, and their response would take another 1.3 seconds to reach you. Now imagine that delay stretched out over light years. That's the reality of interstellar communication. Even if a civilization sent a signal our way, it might take thousands of years to reach us, and our response would take just as long to reach them. The interstellar gap reminds us that the universe is a place of staggering scale, where even the most advanced technology might not be enough to bridge the immense gulf between stars. The sheer vastness of the universe means that even if alien civilizations exist, they could be so far away that detecting them is nearly impossible. As the universe continues to expand, these distances only grow, making the search for extraterrestrial life an even more daunting task. The vastness of space not only challenges our ability to travel and communicate, but also complicates our efforts to find and recognize alien life amidst the cosmic noise. Despite the challenges posed by the Fermi Paradox, our quest to find extraterrestrial life continues. The search for extraterrestrial intelligence, SETI, uses powerful telescopes to scan the skies for radio signals or other evidence of technological civilizations. SETI's efforts include projects like Breakthrough Listen, which is the most comprehensive search for alien communications to date, scanning millions of stars and galaxies. Imagine the excitement if SETI were to detect a signal, a sign that we are not alone. It would be a discovery that would change our understanding of the universe and our place in it. But SETI is not the only effort. Missions like NASA's Kepler and TESS are searching for exoplanets that might harbor life. These missions have already identified thousands of exoplanets, some of which are in the habitable zone of their stars. Even if we never find definitive proof of alien life, the search itself is valuable. It pushes the boundaries of our technology, expands our knowledge of the universe, and forces us to confront profound questions about our place in the cosmos. The Fermi Paradox is more than just a scientific puzzle. It's a profound philosophical question that forces us to confront our deepest assumptions about life, intelligence, and our place in the universe. It reminds us that we are still a young species venturing into a vast and largely unknown cosmos, filled with mysteries and possibilities. Perhaps the answer to the Fermi Paradox is simple. We are truly alone in this immense universe. Or perhaps the explanation is far more complex and nuanced, challenging our current understanding and pushing the boundaries of our knowledge. It's a question that will likely continue to intrigue, perplex, and challenge us for generations to come. But one thing is certain: the search for an answer will continue to inspire scientific inquiry, technological innovation, and philosophical debate for as long as humans look up at the stars and wonder about our place in the cosmos. What are your thoughts on the Fermi Paradox? Do you believe we are alone in the universe? Which theory about the existence of aliens do you find most compelling? Are there other possibilities we haven't considered? Let's continue the conversation in the comments below. Your perspective could shed new light on this age-old question. Share your ideas, theories, and questions. Let's explore the mysteries of the universe together. What if your idea is the key to understanding our place in the cosmos?